Hello students. So today we are going to discuss an important chapter of 12th organic chemistry, haloalkanes and haloarenes. Of course, as the name suggests, haloalkanes. Halo means halogen, that is of the 17th group. Alkanes means organic compounds that are going to include carbon-carbon single bond. So let's start with the methods of preparation of this haloalkanes. First one is going to be with our alcohol, from alcohol. ROH. We are going to mention things as arbitrary things like ROH, and we are going to even discuss with one example each. For this method, we are mainly going to be using three reagents, A being PX5, B being PX3, C being SOX2. Of course, here X is only be going to Cl because other halogens do not form this type of compounds, and X here being chlorine or bromine because iodine or fluorine does not react with phosphorus, giving PX5 compound. It is in covalency of +5. And here X could be again chlorine or bromine. Here another way of asking this reagent would be red phosphorus plus X2. So let's start with PX5. So first one being PX5. Let's take an arbitrary reaction like ROH plus PX5 would give us, of course, RX, that's the major product that we're expecting, plus HX plus POX3. Like in a simpler way to remember this reaction would be writing the reaction in the following way. ROH, as I want X3 here, so I'm going to split the PX5 as PX3, X and X in this way. So when I cut this reaction in this way, I'm going to get the following products like RX plus POX3 plus HX. This would be a simpler way. Then we will be going to see reaction with PX3, where X could be the chlorine or bromine again in an arbitrary way. ROH plus PX3 is going to be formed a major product of RX plus. Here we are going to expect something different because H3PO3 is going to be formed. And again, by balancing the reaction, here we're making 3 of X3. There is 3 halogen atoms are involving. So let's make this 3 and even this as 3. H3PO3, this is going to form. So again, there would be a short form or shortcut of writing this reaction. Let's take a look of it. Let's first write ROH, and ROH. 3 moles of ROH plus. We want X3 going to react with this. So PX3. 3 molecules of RRR and 3 X molecules, it is 3 halogen atoms, together are going to be forming 3 molecules of RX, and the remaining one is this 3 OH ions and phosphorus. So this is going to be forming H3PO3. And again, we could be even getting confused in competitive exams because we don't have this much time to write down and analyze them. So we will see another shortcut that I usually remember it. Like this is PX3. As 3 is smaller than 5, we are going to get lesser products than PX5. So that's why we get here 2 products. Of course, we are going to neglect this number 3 here. So here we're going to get 2 products and here we're going to get 3 products. Just don't balance the reaction here while writing in the exam. To understand this, why we took 3 moles, I have balanced this reaction. Next is going to be our Darzon's reaction or reaction with SOCl2. SOCl2 or Darzon's reaction. We say this reaction being more productive way because it's more yielding way of RX and X being here Cl. So it's the best way to prepare alkyl chloride. Let's write a arbitrary reaction again. ROH plus SOCl2 would form us RX plus SO2 and HCl. Why is this being an easier or a high yielding way, easier way? because SO2 being a gas, it is going to be released in the atmosphere, and HCl even being released in a gaseous form, it is going to be released in the atmosphere. So in the container, we'll be only left with Rx. Here in the following reactions, we need to extract Rx from this other products that are being formed in the reaction. But here we are only left with Rx in the container. So this is being the easiest, or we can say best method, not easiest one, but it's the best method to prepare Rx. That is, X is only chlorine. So it's the best method to prepare alkyl chloride. Next, we are going to see reaction of alcohol with HX. Reaction with HX. Here, in the following cases, we can see that there is no rearrangement occurring here because there is no formation of this carbocation here. But in the following case with HX, there would be a possibility of forming a carbocation that is R+. Hence, we can say that the rearrangement is highly possible in this case. Is possible is that if that doesn't mean that in every case we must rearrange. If there is a possibility, we must surely rearrange to get the correct product. Let's take an arbitrary example again. ROH plus HX. Let's see the small mechanism here. ROH, this oxygen has lone pair of electrons. So this H plus and X minus, it is going to be H plus, seeing this lone pair, it is going to be coming near the O. So if we write the reaction in the such way, exceeding its valency, it gets positive charge here. So it gets broken here because oxygen is an electronegative atom, and positive charge on electronegative atom is likely to be less stable. Hence, it comes out as water molecule, and here we are left with R+. Here we are going to making it rearrange if possible. And next, in the next step, again, X minus is going to be coming and Rx is going to be forming. And in the one of the important statements here would be HX should be in concentrated state, because we want the ions to be splitting here, and it's only possible in a concentrated state. So let's look at the next, like take some few examples up to here. Like, let's see this one. In two different steps, we are going to see this. Like in 4 reagents that we have discussed here, we are going to check it out with 2 reagents. First, let's check out with PX3. PX3, or let's take PCl5 here. PCl3 here. So PCl3, it's going to be forming a major product of Cl. Just what we are doing here is replacing this OH with Cl here. And that's it. And the next one, let's see, same reactant, but with different reagent, HX or HCl in this case. What's going to happen here is, because of the formation of this carbocation, there is a high probability that we should actually rearrange this thing. Because as it's a 5-membered ring, we can rearrange to 6-membered ring. Because in the stability order of ring rearrangement, we know that the 6 is going to be greater than 7 is going to be greater than 5 greater than 4 greater than 3. So we get a 5-membered ring, we should try to make it 6-membered ring to make it more stable. So here we have this ring. So we are going to make it into hexane here, plus charge. And this is going to be forming our sorry. Yep, it's correct. It's Cl. That's it. And this is going to be your reaction. A major change here going to be is this rearrangement from 5-membered to 6-membered ring. And let's take another example here with HX, because we have few models, like easy but important models here to be remembered. And we often make mistakes in them. Let's check out 2 of them. One being a straight chain and another being a ring example. Let's take OH in presence of concentrated HCl. Let's make this. First of all, we are gonna make OH out of this reaction and make a carbocation. Let's check if there is any possibility of rearrangement such that a higher stable of carbocation is going to be forming. Of course, this is a secondary one and this is a tertiary one. So I can shift a hydride shift to hydride shift. I can make a tertiary carbocation that is going to be, of course, more stable than secondary. So let's make it. So like I have shifted this carbocation here. So in the next step, Cl minus is going to be attacking, and here we have the chlorine. This is a good example of this hydration. And the next one of again ring rearrangement, but a bit of confusing than the previous. We have an OH attached here, but in the previous case, we don't have this attachment. But in this case, we have this attachment in presence of again concentrated HCl. Let's check out. First of all, we are going to form a carbocation. Relaxedly, we're going to form a carbocation. And of course, we are going to extend this ring. As we know, in this case, if we take out this ring, this is going to be forming an hexane. In the same way, let's make it as hexane with a hexane carbocation. But we have this extension here, so we are going to keep this extension here. And in the next step, Cl minus is going to be coming and forming this compound. And in the exam, they are going to giving all the four options that are going to be equal and equally confusing to us. Like there could be direct C plus attached here, that is going to be wrong, and there could be even attachment of C plus here, C minus here, or any place in this ring, and that would be evenly confusing for us. So but the correct answer after rearrangement is this one. So let's check out the Lucas test that is going to be telling which alcohol are we actually using to make this RX compounds. So Lucas test. This one we're actually going to discuss in alcohol topic, but just now small way we are going to just quickly see the topic. Lucas test, it requires Lucas reagent. Lucas reagent is this one, anhydrous ZnCl2 plus concentrated HCl. Why we are taking anhydrous? Because concentrated HCl can react with moisture and it could be vigorous reaction. So hence to avoid it, we are going to take anhydrous ZnCl2. And we have, of course, three types of alcohols: tertiary ROH, secondary ROH, and primary ROH. That is alcohols. And turbidity, we are going to discuss a term called as turbidity here. Turbidity is nothing but how fast the reaction is occurring with this respective alcohols with Lucas reagent. When we talk about tertiary alcohols are going to form tertiary carbocation. As tertiary carbocation being stable than other two, it is going to give the turbidity in a faster way. So turbidity is nothing but how faster the reaction is going. So tertiary alcohols react faster, hence their turbidity is in seconds or it's immediate. Secondary is going to take few minutes, and it would for primary would take a long time. And this is all about this Lucas test. Let's discuss about halogenation reactions. That is, we're going to make RX from halogenation reactions, and these are already discussed in our 11th class. Let's see a quick recap of them now. Halogenation first through alkanes. Let's see through alkanes. And this is a famous reaction of CH4, that is methane, in presence of chlorine, in presence of light. It's going to yield few different types of compounds by replacing these hydrogen atoms by each. Let's write quick compounds: CH3Cl, CH2Cl2, CHCl3, CCl4, and these variety of compounds. Major of being CH3Cl here. Of course, all of them are going to be forming. Let's see in alkanes, like let's take an arbitrary one. It's better to take an arbitrary one. X2 in Hv, that's sunlight. It's going to form Rx plus Hx. And this reaction is going to be the free radical substitution reaction. Free radical substitution reaction. And let's check out with alkenes. Let's take this example. Let's write in the line form. It's going to be better. Let's like normally write it. So in presence of X2 in CCl4. Here we are going to use X2 as common and another, let's write another reaction here, X2. But the in presence of which medium it's happening is going to be different. Here in sunlight, in alkenes. In alkenes, CCl4 is polar aprotic solvent and polar aprotic solvent, two different reactions. Here it's going to form our, of course, we're going to break this double bond. Let's break a double bond. C, C, C. As it is, we're going to keep X on upper side and X on upper side. This is all the thing of and this halogen that is going to be attaching to this to the two carbons is going to be upside and downside to two different carbons. It is the plane of this halogen is going to be different. In the next one, in presence of H2O, we are going to make it C, 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 and the same reaction by breaking double bond. One is going to be attached with X and another is going to be attached with OH. This is the difference between H2O and in CCl4 medium. Let's see the reaction in hydrohalogen addition of alkenes. It's a different reaction, of course. It's not a part of this. Hydrohalogenation of alkenes. Let's take an example. Here, hydrohalogenation is nothing complex. It's just addition of hydrogen and a halogen to the same compound. RCH double bond CH2. So here, like in presence of HX again, when we want to react this, H plus and X minus, this double bond is going to be making H minus and plus. And this plus, H plus is going to come near this minus charge, forming CH plus 2 and CH3 here. Because why did I form secondary carbocation? Because secondary carbocation is going to be again more stable than primary carbocation. So I preferred breaking the bond this way other than this way. So let's attach the halogen here. CH2X and CH2. And again here even we can even expect a possibility of rearrangement here. And that's it for today. Let's continue a few more methods of preparation and SN1 and SN2 reactions in the next class.